Hi, my name is Madison Luthi, and this is my video analysis for the IR and NMR lab in organic chemistry. So the first graph that I have here is the IR graph that I created through using the IR machine. So in order to find the spectrum, I placed a drop of the compound onto a salt plate, pushed the plates together, and then put it in the IR machine. And then after that, the machine created the spectrum and the salt plates were cleaned after that. And then the machine was able to do the next one. So this was the graph, the spectrum that I found with the specific compound that I had. So looking at this and using the spectrum summary, for IR, we see a peak at around 1604, which means that our compound is aromatic. We also see a peak around 2857, which represents a C to H aldehyde. But since there is no peak around 2700, this cannot be an aldehyde. There cannot be an aldehyde in this molecule. And then there's also a peak around 2918, which means it's just below 3000, and this would be a C to H sp3 hybridized. And that would be seen in the molecule. And then we have 3025, 3061, 3084 peaks, and this represents from our stretching frequency IR NO to H, which would be a carboxylic acid, but looking at the spectrum, it's not strong and broad, so this would not show up in our compound that we're looking at. And then finally, we have a 3,289 centimeters and 3,371 centimeters, which would represent from our spectrum an N to H amine. And looking at that, you can conclude that the molecule that we have from this unknown number 54, and this IR spectrum would be this molecule right here of benzylamine. And that would make sense because all of these peaks would show up for the benzylamine molecule. It would not be these other two molecules because these other two have a ketone in it, which means that there would be a peak at around 1710, and there you cannot see a peak around 1710. There's nothing in the 1710 range about here on the spectrum. So, but however, in this one, there would be a 1710, and then there would also be a just below 3000. And then in this one, you would still see the 1600, which means it's aromatic, but you would also have to see the 1710 because there is a ketone shown right here. And you would also see the 3300 representing the amine on this side. So from this, we can conclude that the molecule found in this IR spectrum for number 54, for unknown number 54, would be benzylamine. And then the next thing that we did in this lab was find the NMR of a specific compound. So in order to do this, the unknown was placed in a tube with CdCl3 at about a 50-50% of the compound and the CdCl3, and was mixed through inversion. Then the tube was placed in the NMR machine and pushed down, and then we used the computer to actually create the spectrum. And we did actions on the computer in order to find the integrals under each of these, and to find exactly where they line up. So we could see that at the top of our spectrum as well. And then, so once we did that on the computer, Then the printout of the graph was then created, and this is what I have right here. So from the graph, we saw that the ratio was 1 to 1.5 to 1.5 of the integrals. So you can see that this is 1, this is 1.48, which is about 1.5, and then 1.36, which is also really close to 1.5. So when looking at this and the molecules, the possible unknowns chart, what's gained from this spectrum is we see a peak around 7.8, and it is a 2-hydrogen quartet, which is right there. And then we also see a peak around 7.2, which is a 3-hydrogen triplet. And so looking at our spectroscopic, our sheet right here, we can see that around 7.2, 7.8 means that this molecule has an aromatic ring. So when we go over here, we can cross off all the ones that do not have an aromatic ring. And then we also see a peak around 3.5 ppm, which you can see right here on the spectrum. And from our sheet here, we can see that from 3 to 4, this means that we have a hydrogen, and then it's a hydrogen connected to a carbon adjacent to another electronegative atom. So we can see in this molecule, we do have, so we would have a hydrogen here connected to a carbon next to an oxygen, which is an electronegative atom. And so we can also tie this down because we know that since we have 3 peaks, we have 3 types of hydrogens, and there are 3 different types of hydrogens in this molecule. We would not see a peak at around 2.1 because of this C double bonded O, because there are no hydrogens on either side of this. So the molecule, the compound that this spectrum unknown number 42 should correspond to methyl benzoate, which is this one right here. And so once again, this is unknown number 42, and it corresponds to methyl benzoate. And for the IR spectrum, this was unknown 54, and it corresponds to benzylamine in the IR spectrum. And this is Madison Luthi analyzing the NMR spectrum and the IR spectrum for unknown molecules.